My name is Chip Lovett. I'm in the chemistry department. I'm actually a biochemist in the chemistry department, and I'm going to talk about teaching large classes and large classes with a diverse audience. And I'm going to focus on the large intro chemistry course. It's the first semester of general chemistry, and it's a course that I've probably taught about a dozen times since I've been at Williams. The enrollment is almost always over 100 students, and it's often a mix of first year and second year students. And there are many challenges associated with teaching this particular course. I'll focus on three big challenges, and one has to do with the size. So with a class that large, it's important to try and make the class seem small and make the class seem intimate, to try and make the students feel like they're not anonymous, even though I think many of them would prefer to feel like they're anonymous, and to try and connect to all of the students as individual learners. So that's one challenge, to try and make a class that size seem smaller. The second challenge has to do with the fact that this is a very diverse audience, diverse in terms of background and preparation. So typically I'll have students in there who have had 2 solid years of chemistry in high school, including an AP course. And many of these students probably shouldn't even be in there, and they should take our more advanced section. But many choose to take that course. And then we have students on the other end of the spectrum who have had little or no chemistry in high school. And there are no real prerequisites for this course, so anybody can take it. So I've got a range of backgrounds, and it's important to try to make sure that the students with less preparation don't fall through the cracks, while still maintaining the level of the course that's essential for a course of this type. The third challenge that I'll talk about has to do with the fact that in this particular class, probably most of the students don't really want to be taking the class. It's a class that that has to be taken for students who are pre-med, and many students who don't major in chemistry take this introductory course, and for a lot of reasons the students don't particularly want to be there. Many have to do with poor chemistry experiences in high school, where either they didn't understand the material, they don't feel like they ever could understand the material, or they were just taught by memorizing things like memorizing the periodic table or memorizing names, and it was a lot of boring, tedious kind of work that really didn't interest them. So those are 3 challenges, and what I'll do is talk about how I try and address those challenges. So the first challenge in trying to make the class seem small and try and connect with all of the students. One of the things I do with this course is I learn the names of all the students before the first day. I'll do this with all classes, but it's easier with the smaller ones. But I'll typically spend a few hours with Facebook pictures the night before class, and when I go into the first day, I usually know nearly all of their names and call on them by name, and that with a class that size, that tends to get their attention, and I think they realize that they're not anonymous right off the bat. Another thing that's good about this particular course is that the students are in lecture 3 times a week, but they also have a laboratory session and once a week, and the labs typically have less than 18 students in them. And so I make it a point of visiting the lab. So it's a chance, they're in there for 3 to 4 hours a week, and it's a chance to interact with students in in an informal way and get to know them a little bit better. Another thing I do, and this is something that I believe my colleague Jay Thoman actually started when he has taught this course, is their first problem set, which we call problem set 0, is just a short questionnaire that they turn in within the first week of class, where I ask them to write their name, what they like to be called, their interests, why they're taking the course. Even ask them to draw a little picture that will help me remind me of them. One of the questions on that problem set is for them to come by my office and introduce themselves. So not all of them do that, but many do, and it's another chance just to get to know the students a little bit better, and to do that early on. So I think all of those things together help to make the class seem a little bit smaller. And this course is taught in the Wege Auditorium over in the chemistry building, and that room itself actually, it's a very large room, but it's laid out in a way that you can actually move around the classroom and it doesn't feel like an enormous lecture hall. And knowing their names, calling them by name, that also tends to make it feel like it's a smaller, more intimate class. So I think all of those things together tend to help reduce the large size of the class, at least I hope in terms of the way the students perceive it. The second challenge that is dealing with a really diverse audience, there are several things that I do to try and provide enough resources for students who don't have as much preparation, who are going to struggle with the material. First of all, I have lots of office hours. I have a sign-up sheet posted outside my door, and I typically have about 20 office hours, half-hour slots blocked off for students. I encourage them to come in groups. If they want to meet with me individually, they can write that they want to meet alone. But I also encourage students to work in groups as just a general practice, and I think that's helpful, and it's particularly helpful for students who haven't had a lot of background in chemistry. And in addition to the office hours, and students feel pretty comfortable, I think, coming to office hours, and I think that helps a lot. I have weekly review sessions. It's something that we in the chemistry department do for almost all of our courses, but once a week in the evening I'll have a review session, and in this class it's usually pretty well attended. I would say that it's not uncommon to have 30 or 40 students show up for these review sessions. And they're informal, and it's a chance for the students to ask questions, and we can go over material from the lecture, we can go over quizzes, we can go over problem set questions. Quizzes and problem sets are another way to make sure that students don't fall behind. Students have problem sets that I think there are probably 7 or 8 during the course of the semester. So these are practice problems. Learning chemistry is like learning another language, and it requires a lot of practice. It requires practice getting familiar with the language. It requires practice doing the mathematical problems, and having the problem sets is a good way for the students to make sure they're keeping up with the material. I also give quizzes fairly frequently. Every 2 weeks or so there are quizzes, so that the students can assess, and I can assess how well they're doing. And if I find on an initial quiz that a student isn't doing well, or in the early problem sets, I'll either make a note on the quiz for that student to come and see me, or I'll send him or her an email saying to come and see me so we can work on that. But I try hard to make sure I know when students are having trouble with the material, and to reach out to them and make sure that they get caught up. The last challenge that is trying to make the class interesting, enjoyable, and make the students feel like they want to be taking the course and want to learn the material has to do with I think the way that I and others teach this course and have for many, many years in the department, and that is to include lots of chemical demonstrations, a lot of use of molecular models and visual tools to help the students try and understand what's going on. I do a science camp with my colleague Dave Richardson in the summer for kids who are in 5th and 6th grade, so they're 10 to 12 years old, and we've been doing this for over 10 years now. And when we first started it, we had all different branches of science incorporated. We did biology, we did chemistry, we did physics, and what we found was that the students at that age just really loved doing chemistry. They liked mixing stuff up and seeing things change color and bubble and pop and make noise, and they just loved, and they loved dealing with the instruments, the pH meters, and they just really have a blast with that stuff. And at 12 years old, these kids just love chemistry. They love to play with it. They get excited about seeing what's going to happen when they mix things together. And somewhere between that age and when they come to Williams, they lose a lot of that excitement. And I think a lot of that has to do with the way chemistry is taught in high school. But it really is essential for students when they're learning chemistry to realize that what we're dealing with are molecules that are objects, that they have shapes and sizes and structure that they can see at least models of or pictures of, and they can try and imagine these things as real objects. I think that's a problem for a lot of students of chemistry, is that we're dealing with things that are so tiny, and they learn unfamiliar names that they connect to unfamiliar symbols, and it has virtually no meaning for them unless they can associate that with an object. And so having molecular models, having chemical demonstrations to actually show what's going on when we write chemical equations on the board, or symbols, or when we're doing mathematical problems to try and figure out how much of this or that is produced or consumed, that they can relate that to things they can see and things that they've seen in class. Of course, the laboratory allows them to do that as well. So all of these things, I think, help to make the material more interesting and easier for them to understand. Of course, as many of their senses as we can reach with lectures, the better they'll understand the material. As it turns out, this college in this chemistry department has a very long history of chemical demonstrations, and we even have we have an entire room that's chock full of demonstrations, and we use them pretty extensively throughout our curriculum. But this history actually goes back to about 1800, when the very first chemistry instructor here, they called them tutors then, was a man by the name of Chester Dewey, who was a class of 1797, but after he graduated from Williams, he was actually convicted of forgery and sent to jail for a couple of years. And when he was in jail, he actually learned chemistry. And he came back and he taught chemistry here at Williams, and according to the stories, he used to have an old shack where he used to do chemical demonstrations, in the wee hours of the morning or late at night. He'd get all his chemistry students together, and they blow stuff up and whatever, but things that probably were frowned upon by the administration at the time. But but there is a long history of chemical demonstrations in our department and at Williams. So these are some of the things that that I do and my colleagues do as well in this course, to try and make these large classes that we teach and necessarily have to teach seem smaller, less intimidating, and more interesting.